In this video, we're going to talk about naming aldehydes. So let's first talk about what an aldehyde actually is. So this right here is an aldehyde functional group. Whenever you see this, the molecule is going to be an aldehyde. Now, there are different functional groups which look similar to aldehyde. This is called a ketone, and it is not to be confused with an aldehyde. The aldehyde has a hydrogen attached to the carbonyl group, and the ketone has 2 carbons attached to the carbonyl group. So that's the difference between a ketone and an aldehyde. So let's start with our first example. How do we name this aldehyde? So first thing we want to do is count the longest chain. And when we count the longest chain, we can see that we have 6 carbons, which corresponds to hexane. But instead of writing hexane, we're going to write hexanol with an AL at the end. That's the suffix for aldehydes. So now let's look at a different example. So here we have 4 carbons, which would be butane, but it's going to be butanol because of the aldehyde. So now let's start adding substituents. And there. So in this situation, if we want to count the longest chain, you can see that we have 5 carbons, which would correspond to pentanol. And then substituents, we have a methyl on 3, so 3-methyl pentanol. Next, we're going to look at another aldehyde. And the aldehyde functional group doesn't always have to be on the right side. It can also be on the left side. But it's always going to be at one end because it ends in hydrogen. So in this situation, we have both an alkene, which is a double bond between 2 carbons, and we have an aldehyde. We're going to start counting where the aldehyde starts because that has priority. So 1, 2, 3, 4. Now we can see that we have 4 carbons, right? So that would correspond to butane. However, since this is a double bond in here, we're going to call it butene. But we're not going to call it butene, we're going to call it butanol. So the E is because of the double bond, the Al is because of the aldehyde. And then in terms of numbering, we have to specify which carbons the double bond is at. The double bond is in between carbons 2 and 3, but you're going to take the lower one, so take 2 and put it behind the butanol, and there's your name for this aldehyde with a double bond between 2 of the carbons. So now let's talk about a more complicated example. How do we name this aldehyde? You can see that we have a lot of functional groups. Right here we have what is called an ether, and the name of this substituent is going to be called methoxy. We have an alcohol group, and the name of this is going to be called hydroxy, and we have an amine, and it's going to be called amino. Now the aldehyde takes priority over all of these other functional groups. It takes priority over the ether, the alcohol, and the amine. So because of that, we're going to start counting right to left to give the aldehyde carbon number 1, and then we're going to end at 5 carbons in this compound. Now, the methoxy is going to have carbon 2, so it's going to be 2-methoxy. The alcohol is going to have carbon 3, so it's going to be 3-hydroxy, and then the NH2 has carbon 4. So we need to write the parent name first, and so we have 5 carbons, so that's going to be pentanol. And then we want to write the substituents in alphabetical order, so amino comes first because A is first in the alphabet. And then hydroxy comes first because H is before M in the alphabet. And then we have 2-methoxy before the pentanol. So there's how you name this one. Now let's talk about an aldehyde that is going to have a ketone on it. How do we name this one? So first thing you need to know is, do we prioritize the aldehyde or the ketone? So we're actually going to prioritize the aldehyde. So the parent chain is still going to have the aldehyde suffix. So we're going to start naming from right to left. 1, 2, 3, 4, 5, 6. So we have 6 carbons, which would be hexanol. And on position 3, we have, whenever you have a carbonyl or an oxygen double bond to a carbon like that, it's going to be called an oxo group. And then bromine is just bromo. So it's in position 4, so it's going to be called 4-bromo. Now B comes before O in the alphabet, so therefore we're going to put the bromo first. So 4-bromo, 3-oxohexanol. That was a mistake. Alright, so let's say that we have a situation where we have what is called a carboxylic acid and an aldehyde in the same compound. Which one is going to take priority? So you need to know that carboxylic acid has the priority over the aldehyde. The only difference between a carboxylic acid and an aldehyde is that on the carboxylic acid you have an oxygen attached to the hydrogen, but in the aldehyde you don't. It's just a lonely hydrogen. So we want to count the longest chain, and we want to start counting at the carboxylic acid group because that one has priority. So you put that as number 1, and then you count until you get to the aldehyde at the other end of the straight carbon chain. And so we have 3 carbons which would correspond to propane. However, because the carboxylic acid here has the priority, we're going to call it propanoic acid. And then you can see that on carbon 3 we have a double bonded oxygen, and as we said, that's called an oxo group. So this is going to be 3-oxo, and this should be one word, so there should be no space between the oxo and the propanoic, but there is a space right here between the propanoic and the acid. Now you're going to see examples if you're taking organic chemistry where you have substituents that are going to be ringed structures. So how do you name a straight chain carbon aldehyde like this when you have these benzene rings attached? So first of all, we want to find the longest chain of carbons, which would be, this would be 7, and that's associated with heptanol. Now you can see that on carbon 3 we have a benzene ring and a carbon. So we have 7 total carbons because benzene ring has 6, plus the 1 here, you have 7. Now on this one we have a benzene ring and it has 6 carbons. You need to know that whenever you have a benzene ring and an extra carbon, it's going to be, the substituent name is going to be benzyl, and whenever you have an only benzene ring without any extra carbons, it's going to be called phenyl. And this time the benzyl is on carbon 3, so we're going to put a 3 below it, or behind it, and then the phenyl is on carbon 5, so we're going to put a 5 behind it. And to put these substituents in the name, we're going to alphabetize it, so the benzyl comes first because B comes before P in the alphabet. 3-benzyl, 5-phenyl heptanol. So that's it for this video. Come back next week and we will talk about aldehydes and ring structures.